So the second type of sequences we're going to look at are these geometric ones, and this time we're multiplying by something from there to there each time. How do we figure out what it's going to be? Well, we could do this by just taking the second term divided by the first. 8 divided by 10 tells me that my ratio is going to be 0.8. I can check it by doing 6.4 divided by 8 or 5.12 divided by 6.4. Each of these would give a common difference, a common ratio of 0.8. First term, clearly just 10, like before. This brings us to our formulas for the geometric series. Same idea here for this one here. The first one, and you're timesing by n-1 ratios. This is your sum formula, slightly bigger this time, and it can be used the other way around as well. And this one here is a sum to infinity formula. This is the idea if you keep a sequence going on and on and on forever, what would its limit be? That won't always happen. The sequences 1, 2, 4, 8, 16 and so on gets bigger and bigger and bigger all the time. So there wouldn't be a sum to infinity. But turn it round the other way, 16, 8, 4, 2, 1, it keeps getting smaller and smaller and smaller. Then this would have a total. It would reach a place where it would never get any higher to. And that's the reason why that this one works, is that this one's ratio is lower than 1, whereas this one here, its ratio is 2, and that's why it gets bigger and bigger. Basic formulas then to find out, I'm asking to find out what the sixth term is, and my formula for that was AR to the n-1, or 10 times 0.8 to the power of 5. 6 taken by 1 is 5. That's how I got the 3.2768 on there. Similar one, if I want to find out the total of them. The total formula, unfortunately it is in the top corner but covered by the recorder. The total formula is A R to the n-1 all over, I have got it around the wrong way, all over 1 minus R, so it could be used either way around. 1 minus R to the n all over 1 minus R. A, we've got is 10 here. R is 0.8 all to the power of n 6 all over 1 minus 0.8. And if we tap that into the calculator, we end up getting 36.89. This one, in fact, has got a sum to infinity, in that it's getting smaller and smaller and smaller and smaller every time. The ratio here is lower than 1, and so the sum to infinity does exist. The formulas, A over 1 minus R, 10 over 1 take away 0.8, or 10 divided by 0.2. The sum to infinity here is 50. If you kept on adding forever and ever, you get to 50. So another exam question here. Let's move the recorder so you can see it. It's again a slightly more interesting one than the bog standard, but it does say the sum to infinity. So you do need that formula. Sum to infinity, A over 1 minus R. And it says that it's 4 times the first term. Well, we know the first term's A, so 4 times the first term is 4A. And we want them to be equal to each other. And we need to be able to solve this equation here then. Well, what I'd do is, first of all, just divide both sides by A, I suppose. That there's an A here and there's an A here. So my next line would be 1 over 1 minus R equals 4. You could just flip these things upside down now, I suppose. 1 minus R equals a quarter. And so R must be 3/4. Lots of other ways of doing the rearranging there. At this point here, you might have just wanted to multiply both sides by 1 minus R. We can do that. Then multiply out the bracket. Then add the 4R to this side. Take away the 1. R equals 3/4. You could have done that earlier and then divided by A later. Lots of different ways of trying to solve that. But there you go. We've got R is 3/4. We know R is 3/4. This one here, it now also tells us that A is 48. And we want N, the first 10 terms. So now using my sum formula to find the total here, it's 10, no, it's 48, lots of 1 minus 3/4 to the power of 10, all divided by 1 minus 3/4. I wouldn't try and do that all in one go on the calculator. I'd probably be doing, I'd work that bit there out first, then I'd times it by 48, and then I'd divide it by a quarter. The grand total of this is 181.1878. I've done that to 4 decimal places because it told me to do it to 4 decimal places. So go back and check sometimes on the roundings.